Okay, what we're going to do today is demonstrate what a Frostpoint is for checking insulating glass to make sure the seals are working properly so that we're in compliance with certain standards that we have to meet. Those standards would be ASTM standards that are for the Frostpoint testing that we're going to do, and that's the ASTM C5, 546, and 576. And these also allow the glass to be in compliance with the ASTM specification for durability for insulating glass testing, and that's the ASTM E2190 series. What I'm going to do now is show a couple different devices that can be used to obtain frost points from insulating glass. The first one is I'm going to chop up some dry ice. And dry ice is what we use as the refrigerant to drive the glass temperature way down so that we can tell whether or not there's condensation or conditions within the insulating glass that would form condensation or frost on the glass. Now, when you're dealing with dry ice, remember that it's minus 108 degrees Fahrenheit. So that's pretty cold. So you need to wear gloves. Make sure that you're protected so that if you're doing anything with it, that you don't get any of it on you. So now I'm just chopping it up into smaller pieces so that I can charge little devices here that I'm going to use to actually determine frost points or check to see if insulating glass has a situation where I'm going to get condensation. Now, what is condensation? There's some very formal definitions of it. I use a very simple method. Condensation is when warm, moist air hits a cold surface. And that's what we're concerned about in an insulating glass unit. Whether or not we got a situation where we're going to have condensation in the unit. So I'm going to put some of these in this device right here, which is actually a popper cup with tubing on it. These are actually made from copper fittings that are swept together, and then I put insulation around them. We will take the dry ice and actually put it in the device itself. As you can see, it's we're getting a little chemical reaction here because I also put a little alcohol in there to help this act as a refrigerant. It gets pretty cold at the tip of this device. I've measured them down to around minus 80 to minus 85 degrees Fahrenheit. Normally what we want to do is make sure we're somewhere below a minus 65. And then we put it on the glass to actually hold it on that particular insulating glass unit for a period of time. That period of time is normally determined by the glass thickness. In our particular situation, for the glass that we're using, we're going to use a 5-minute timer.
What Bill is loading up right now is a manual version. In the standard, you'll see this is what they show as a typical Frostpoint device. And dry ice is loaded into the back with some alcohol bath around it to get better conductivity, better connection to this plate and this puck that comes up. So he and Jim Spetz, Bill Lingnell and Jim Spetz, came up with a handheld version of this. This one can go in the field, but not as easily as their little quick tester can go.
And one of the things that we use this for a lot is somewhat of a go, no go. And I'll demonstrate that a lot with some other devices that we plan to use to show how things work for us. So I got a pretty good charge in there now. I tamp it in with an ice pick just to make sure that I'm getting pretty well loaded up. Takes a few minutes, and then it'll get into, as Randy mentioned, the temperature that we want it to get down to, and we'll have it loaded. So
this is a simplified version of this device here. This is what we're seeing more now in the laboratories, what your devices are, your units are being tested against. But it's the same idea. We've loaded dry ice and some alcohol in here, and it's pressing up against a plate here. This has some more sophistication. Intertech has developed these that have a little heater in there to help us more quickly turn the temperature, but it's this little puck up here that's going to reach that minus 40 to 70. That's the same little puck that's here.
And this is a 1-inch diameter. This one is the same as this one right up here at the top. So as Randy mentioned, it's basically a very similar technique. Now, I use a little denatured alcohol as part of my refrigerant fluid to get everything going here. This is the fun part. People think we're doing Halloween activities, but actually we're cooling this guy down here. So you can see at the tip of my device here, it's starting to get pretty cold. And sometimes I'll take and do a temperature reading. I can do it with my gun here. I'm minus 21, minus 30. And it'll get down to probably about minus 60 to minus 80 degrees Fahrenheit. And then we're ready to actually go ahead. We put a cap on it. This particular situation, I have a hole in the top of the cap that acts as a vent hole. When we first made this device, the first one we made, we didn't put that vent hole on, and the pressure built up in there enough that it popped it off, obviously. So now we use the vent hole as part of our.
The thing to remember when using this device then is with that vent hole here, he's got alcohol in here that's been super cool. And if you tip it and splash some of that out, especially if you've got a cloth glove, it's going to sit right on that glove and freeze your hand. So you want to make sure you hold the unit upright and be careful of that vent.
And then the purpose of what we do is this particular surface is flat up against the glass, again, for a period of time. We're going to use 5 minutes for what we're going to do on this experiment. So I'll put, let's see, I think this is the one we want for this guy. Okay, I'll let that little top off there. So it's getting down there. Now we're going to ask Dan to kind of hold this on this piece of glass, this insulating glass unit, for a period of 5 minutes. So we can start something else.
Sure. And the key here is that it needs to be held square against that glass. So we have intimate contact between the tip of the copper up there and the surface of the glass. What that will then do is cool. If this is surface 1, it'll start cooling surface 2. If we have a relative humidity that's high enough in there, we'll start to see frost occur at that point. But it's going to take him about 5 minutes.
In the field or even in the laboratory on occasion is a freeze spray. Now, this doesn't give you what I call a quantified number, but it does give you some information with regard to whether or not you have a unit that's on its way down or it's not going to hold a very good frost point. So what we do with this one is we take and we spray it right in a certain area that we're interested in finding out, where the frost point might be. So I'm going to spray this one.
So now as he's sprayed that, we've super chilled this surface 1. That's transmitting through the glass to surface 2, which is on the inside. If the relative humidity is high enough, which would mean the desiccant is perhaps depleted, then we'll start to see frost occur.
Right. So I got this very cold. I chilled it very cold to the point where there is frost on here. It's on the number 1 surface of the insulating glass unit. What we want to know is whether or not there's anything happening inside the insulating glass unit on the number 2 surface. So I'm going to wipe this off. I've got some isopropyl alcohol and a rag. Now I've taken all the stuff off the number 1 surface. So what you're seeing now is inside the surface of the glass, in the airspace area. So I've got frost in this particular unit right now. So it would, more than likely, if I was in the field and I saw this happen, I would know that this is a failed unit. Now, if I go ahead and do this examination and I find this, then I don't usually go further with regard to checking other items, in the field or in the laboratory. So this is a quick check on some things. It doesn't take as long as what Dan's doing. Dan's doing a marvelous job of holding on over there. He's probably got about a minute left on his particular issue. And then we'll go over and see what happens on his. So this one did what we thought it could do.
Okay, so again, what he meant by failed is that the desiccant that's in this unit has been saturated and it's allowed, there's a constant path of moisture slowly coming in around the perimeter seals. The desiccant sucks that moisture up. When it saturates that desiccant, it can no longer take up any more water vapor, that water vapor condenses off here. Now I can segue right into my tablet if you want. Okay. So when we started, we've got another device in here called an EyeTape. It has a number of sensors on it, including a conductivity sensor for the argon content, but it has an RH sensor, and then the chip that's inside it, the computer in there, will convert that RH into Frostpoint levels. It's powered inductively, like how you charge your toothbrush. There's a coil on the inside. So all of this is contained inside this seal. Before we cooled that down, I took a reading, and what we can see on the tablet, it communicates via Bluetooth. We can see that we've got a relative humidity of 35% with a frost point of 14. I'm going to take another manual measurement, and that's come down a little bit. That condensation is leaving that unit. What we'll actually see is that RH sensor is sensitive enough that as we coat the glass with that moisture, you'll see it actually dry that cavity in there, and then it'll rebound back up again.
Okay, Dan, it looks like you've been up there long enough now. Let's take a look and see what we've got here. I've got my rag filled with alcohol, and we've got frost on the glass. Number one surface. Let's see what's happening inside in the airspace. Uh-oh. We've got frost in this one also. Now, this is an indicator that this unit has probably had its desiccant overwhelmed, and it's not capturing any more moisture and moisture vapor in the system. So eventually this will go into a full fogged unit as a seal failure. I'll wipe that off again just to show what happens there. So that's what a frost point actually looks like. We're dealing with actually testing whether it's in the lab or in the field. And a lot of times we want to know what that level is. And that's somewhat what Randy explained when he checked it with his EyeTape. Very useful instrument to determine where certain things are.
So within the standard, there's, like Bill was saying, there's two ways that you can determine this exact frost point. One is by adjusting that temperature up and down. The second one is by looking at the amount of frost that you actually see. And within the standard, they've got a correlation chart that shows you if there's more frost. So let's say you've got that set at 30 and you're seeing, say, this much frost, then you know that there's an offset for that, and it might be like a 25 or a 26. So by changing the temperature, which takes a little while, and by looking at the amount of frost, you can determine what that exact frost point is.